Welcome pre-cal students to the homework help video on the factoring problems. There are 8 factoring problems that I've given you. So let's go ahead and get started with these. Okay, here we go. Let's factor this binomial. The first thing you always need to do is pull out what's common. Obviously, there's nothing common in both terms you can pull out. So from there, you ask yourself this question. Are these two terms perfect squares or perfect cubes? Well, obviously they're perfect cubes. You know the cube root of x cubed and you know the cube root of 27. So whenever you're dealing with perfect cubes, you put a little parentheses and a big parentheses. And then in your mind, you take the cube root of x cubed, and that would be x, and you take the cube root of this term, which would be 3, because 3 times 3 times 3 is 27, and whatever this sign is right here, you bring it down. Easy enough. Now, whatever this term is right here, in your head, you multiply it by itself, so x times x is x squared. Whatever this term is right here, you multiply it by itself. 3 times 3 is 9, so you put it over here. And then you multiply these two terms together, so x times 3 would be 3x. All right, and then remember, whenever this sign here is positive, that means this sign here will be negative. And of course, the other two signs are going to be positive. This sign here, the x squared, this first term here will always be positive, and this last term here will always be positive. The only thing that changes is this term right here. If this is a positive sign, this will be a negative. And if this first sign here was a negative, then this would be a positive, okay? And let's continue on. Here we go. Problem number 2. Well, first of all, we're going to have to pull out what's common, and I'm kind of doing this in my head as I go. It looks like 2 will go into 16 and 250. There might be a bigger number, so we'll see as we go along. Also, there's 5 u's in the first term and 2 u's in the second term, so we can take 2 u's out of both terms. So let's see what we're left over with. We should be left over with 8u cubed minus 125. Now let's check and make sure we're right. If we take 2u squared times 8u cubed, we'll get 16u to the fifth. If we take 2u squared times negative 125, we'll get negative 250u squared. Okay, now we're left over with a binomial, so we ask ourselves, am I left over with perfect squares or perfect cubes? Well, both of these terms are perfect cubes. You know the cube root of both of them. So we bring down our 2u squared, we put a little parentheses and then a big parentheses, and then here we go. In our minds, we take the cubed root of this first term, and the cubed root of this first term would be 2u. We take the cubed root of 125, and that would be 5. And then whatever this sign is, bring it down. And now we take this first term, and in our head we square it. And if you square 2u, you'll get 4u squared. Then we take the second term right here, and we square it, and we put that right over here. 5 squared is 25. And then we multiply these two terms together right here. Well, 2u times 5 is 10u. And now whatever this sign is right here, we always put the opposite sign here, and this first term here is always positive, and this last term here is always positive. Okay? All right, let's move on. Okay, let's factor this binomial right here. First of all, let's see if there's anything common that we can pull out of both terms. We have an 81 and a 16. I know of no number that goes into those two numbers evenly. Also, I noticed there's x, 4 x's with this first term here, but there's no x's with this term here. So there's nothing common we can pull out. So next, because we're dealing with a binomial, we look and we say to ourselves, okay, do I have perfect squares or perfect cubes? And these two terms are both perfect squares. Okay, so with that in mind, I'm going to go ahead and put 2 little parentheses. Now you should remember what to do. Whenever you're dealing with perfect squares, remember you always want your first term to be positive and the second number to be negative, and we have that, so we're good. Okay, in our minds, we're going to take the square root of 81x to the fourth, and that's going to be 9x squared, and then right over here we're going to put 9x squared. And then our heads, we take the square root of 16, and of course that's going to be 4, so we put a 4 here and a 4 here, and we make one positive and we make one negative. Now the only thing is, you have to be careful of when you get into pre-calculus and a higher level factoring, sometimes after you're done factoring, you can then factor again. Now notice this binomial right here. 9x squared is a perfect square, and 4 is a perfect square. However, please listen to me. Whenever you're factoring perfect squares, the first term has to be positive and the second term has to be negative. And obviously we don't have that in this parentheses. Both of your terms are positive, so you cannot factor this first parentheses again. However, look at the second parentheses. We are dealing with two perfect squares, and the first term is positive and the second term is negative. So we can take the second parentheses and factor it again. So in your heads, take the square root of 9x squared, and of course that's going to be 3x, because 3x times 3x is 9x squared, and then take the square root of 4, which would be 2. So put a 2 and a 2, make one positive, make one negative. And now no other parentheses can be factored any further, so we know we're finished. Okay, moving on. X cubed minus 8. Well, this is a pretty simple binomial to factor. First of all, we notice there's nothing common you can pull out of both terms. Secondly, we do notice we have a perfect cube here and a perfect cube here. In other words, we know the cubed root of both of those terms. So I'm going to put a little parentheses and then a big parentheses. Okay? In my head, I take the cubed root of this term here, and of course the cubed root of x cubed is x. I then take the cubed root of 8, and that would be 2, and then whatever the sign is right here, I bring that down and put it right here. Now take your first term and square it, and when you square this first term, you'll get x squared. Then take the second term right here and square it, and you'll get a 4. And then multiply these two terms together. X times 2 is 2x, and whatever this sign is right here, you always put the opposite right here, and the first term here is always positive, and the last term is always positive. So there we go. Moving on. Okay, now when I look at this, I realize I cannot pull out anything common out of both terms. Both terms do not have an x, and there's no number that I know that goes into 216 and the number 1 evenly. So I look at what I have left over, and I realize I have a binomial, and this here is a perfect cube, and this here is a perfect cube. I know the cubed root of both of those. Excuse me for a second, students. Sorry about that. I know the cubed root of both of those terms. So because I'm dealing with perfect cubes, I put a little parentheses and then a big parentheses like this. Okay, so here we go. Let's take the cube root of this first term right here, and to be honest with you, I'm not quite sure what that is. I think it's 6. 6 times 6 is 36. Times 6 would be 36 carry your 3, 216. So the cubed root of 216 is 6, and the cube root of x cubed is x. Now we take the cube root of this term here in our heads. The cube root of 1 is 1. Bring down your positive sign and put it right here. Now we take the first term, 6x, and we square it. 6x times 6x is 36x squared. And then we take this term here and we square it. 1 times 1 is 1. Then we multiply 6x times 1 and we get 6x. Okay? Now, whatever this sign is right here, we put the opposite sign right here, and your first term here is always positive, and your last term here is always positive. Okay? And we are moving on. That is the factorization. Okay? All right, 32 cubed minus 4. Now, the first thing you do is pull out what's common. Obviously, both terms do not have an x. However, we can pull a 4 out of both terms. So I'm going to factor out a 4, and I'm left with 8x cubed minus 1, which is actually the same thing we factored right back here, almost, if not identical. So no, not quite. It's a little bit different, but it's going to be very similar. So we're left over with 8x cubed minus 1. So we say to ourselves, okay, do I have a binomial that has perfect squares or perfect cubes? Well, both of these terms are perfect cubes. So I bring down my 4, I put a little parentheses and then a big parentheses. Okay, now the cubed root of 2x cubed would be 2x, and the cube root of 1 is 1, and then bring down your negative sign. Okay, now take your first term 2x and square it, and you'll get 4x squared. Take your last term and square it, and 1 times 1 is 1, and then multiply 2x times 1 and you will get 2x. Now if this sign right here in the middle is negative, then that means you put a positive sign here. Your first term is always positive, your last term is always positive, and you are finished. Okay, moving on. All right, let's go ahead and factor. First of all, we pull out what's common. Notice that 2 goes into both of these numbers, so I pull out a 2. Notice I have 3x's in my first term, and notice I have 1x in my second term. So I'm going to pull out 1x. And when I do that, I'm left over with x squared minus 16. Now let's make sure I'm right here. 2x times x is 2x cubed, and 2x times negative 16 is negative 32x. So I say to myself, what am I left over with? Well, I'm left over with a binomial, and both of these terms are perfect squares. So since I'm dealing with, oh, and by the way, they're both perfect squares, and the first term has to be positive, which it is, and the second term has to be negative, which it is. So I'm going to go ahead and put 2 little parentheses, and in my head I take the square root of this term and I put an x here and an x here, and then I take the square root of this term in my head and I get a 4, so I put a 4 here and a 4 here, and then you make one positive and you make one negative. And we're moving on. Last problem on the homework assignment. Okay, first of all, we're going to pull out what's common. So I know that a 2 goes into 2 and 32. Notice I have 7 x's here and 3 x's here. So I'm going to pull 3 x's out of both terms. Now, if I do that correctly, I should be left over with x to the 4th minus 16. Now let's check and make sure this is right. 2x cubed times x to the 4th is 2x to the 7th, and 2x cubed times negative 16 is negative 32x cubed. Now let's look at our binomial. I notice the first term is positive and the second term is negative, and I notice I have perfect squares. Both of these terms are perfect squares. So I'm going to bring down my 2x squared, and because we're dealing with perfect squares, I'm going to put 2 little parentheses, and here we go. The square root of x to the 4th is x squared, so I put an x squared here and an x squared here. The square root of 16 is 4, so I put a 4 here and a 4 here, make one positive and make one negative. Now, this parentheses right here cannot be factored any further. Now, it's true this is a perfect square, and it's true this is a perfect square. And when you're dealing with perfect squares, though, don't forget the first term has to be positive and the second term has to be negative, and we don't have that. Now, listen, if we're dealing with perfect cubes like x cubed and make this an 8 right here, then they can both be positive. That's fine. Okay, but we're not dealing with perfect cubes. We're dealing with perfect squares. Okay, now this parentheses can be factored again because this is a perfect square, this is a perfect square, the first term is positive and the second term is negative. So I can factor that last parentheses one more time. Okay, so I'm going to bring down 2x cubed, I'm going to bring down x squared plus 4, and then I'm going to factor this last parentheses here. And the square root of x squared is x, so I'll put an x here and an x here. The square root of 4 is 2, put a 2 here and a 2 here, make one positive and make one negative. This is the factoring, students, that you need to be amazingly familiar with, and we're going to have a quiz on this next week, okay? So really, really, really make sure you're doing your homework and understanding how to do this factoring, okay? Call or email if you have any questions.